they're able to find the distance to Venus and like triangulate that. I don't care about the triangulation part. I want to focus on the radio waves somehow being indicative of the distance to Venus, which was one of the proofs posted by Simon Dan in one of his recent videos. Radio waves to Venus, and I want to know if anyone has the answer to this. How do they know that's where the radio waves are coming from when they intercept them? Do they have some type of like symbol attached to them or something? Like, how do you know when you shoot one out, you're going to get back the same one?
Anybody? This is
Divination. They're gonna have a chart, and then they're gonna point at what they think is the most reliable assumption. Story.
Well, if you point a radar at a car on the highway, it bounces back, and that's how you know.
Right, Brenda. I understand that. Radio waves and what is it that submarines use?
Sonar. Submarines use sonar. And then there's radar.
It's similar. Yeah, similar concept is what I'm saying. What I'm saying is when they shoot it out, how do they know? Because radio waves supposedly are coming from all different types of places. How do they know it's the one they shot at Venus coming back to the interceptor?
There's nothing else out there.
There's plenty of stuff. They talk about different types of radiation, radio waves coming from all different types of things.
Oh, it would be by the frequency, right? And by the direction, by the frequency and the direction. So there's radio waves, but they're coming from all different directions. But radar is directional. So you point it directly at an object and it bounces back and then you time that. And by that you can get the distance.
How to get the timing?
That's the question I've got about this. Maybe you could help me on this, because I pondered this, and obviously within a static system, it's quite easy, or with just something like what you said with cars, etc. You could be quite easy calculate the way in which you'd have to send the beam at the car, the speed the car was going, the shape of the car that would cause the reflection and rebound. That seems fairly. When you then kind of put that into of celestial dynamics, where you've not only just got orbits, but you've got movement around the center of the galaxy, movement around the great attractor. How the hell do they calculate which angle to fire to Venus and hope that the rebound effect would be within Earth's path? Its orbit. How do they do that, Brenda? Have you got any?
Yes, because it's a reference. It's a reference frame.
Yes.
So the radio waves moves relative with it. You're saying it's not independent.
I don't understand the question. So we're in the reference frame of the solar system, and so within the solar system, Venus is not moving.
Why are you trying to learn to answer it? Or do you want me to explain it again? How can you? That does not make sense, Brenda.
What doesn't?
Yeah,
make sense
Brenda's
about
not
the
making
solar
a lot of
system?
sense this morning.
What doesn't make sense about the solar system?
What doesn't make sense is you're doing it again. So you've asked a question, it's getting answered. What doesn't make sense is you saying that you don't understand something and then proceeding to answer anyway. If you don't understand the question, then presumably it needs clarity or repeating, rather than you just trying to answer something you don't understand. That makes no sense.
Okay, then go ahead and repeat.
Try again, Adam?
So we are trying, aren't we, to send a signal from here to Venus and back, which in a static setup would be straightforward in terms of calculating. Within the calculations that apparently are done, are they calculating for movement with regards to the solar system, not just orbital mechanics, but with regards to the solar system around the galactic center, and then obviously the galactic movements around the great attractor? Because surely those movements must be calculated if you're going to catch the return signal.
No, you don't have to take those into account.
Okay.
Because as a
Okay.
function of distance,
And what about
Why not, Brenda?
because they're very, very, very small. That's why.
All
Sorry.
66,000 miles per hour we're traveling
Yeah, but
in
it's over
one
vast,
of those reference frames.
Yes, but it's over vast distances. So as a proportion
What?
to the distance, it's very small.
The radio wave.
I'm sorry, what?
Radio
It's
wave
massive.
travel.
Radio waves travel at the
What
speed
speed
of
is the
light.
radio wave travel?
The speed of light.
Uh-huh.
Radio waves are light.
Uh-huh. Uh-huh.
Yeah. So I'm not getting the problem.
The problem is the timing. So obviously they're looking for a return signal in a particular time frame, aren't they?
Yeah, you aim it at the object that you're
But
going
yes.
to measure the distance, and then you get the return. What's so hard about
Yeah.
that?
Need clarity. I know. I stated it as fact.
How do-
Yeah, I don't need clarity. I just need a yes.
How?
So given that timing would presuppose the orbital mechanics that the spherical Earth has, you would automatically be assuming these vast distances and calculating your times based on the vast distances you've already presupposed.
No, they aren't presupposed. They're already known.
Sorry, Brenda. I'll say it again. The timing of the return signal will be based on orbital mechanics, a spherical presupposition for Earth, and the distances that those things give you. So you will be basing the return signal and how long it will take on a... Look, I haven't finished talking. Supposition of a spherical Earth and the angles measured to give you these parallaxes, transitions, that's already calculated. So you've already got an assumption of how long it will take for it to come back based on a sphere Earth pushing the distances of these lights in the sky to astronomical distances. So your return signal is based on the astronomical distances when you presuppose Earth is a sphere and push these lights to those great big distances. So when I asked about the timing, you're going to be looking for a return signal based on that time frame when you push these lights out to vast distances because you've presupposed Earth spherical.
No, it's just a function of how long it takes to get there and to come back.
Yes, Nathan, that's correct.
So you don't have to take those things into account. It's simply a function
Where?
of how
Where? Sorry, Brenda, there be the distance that you've presupposed it's at, based
you
on a
don't.
spherical Earth, and you pushing the distance. I'm finished. Yet your hand wave's getting totally demolished. No, it's based on presupposing Earth is a sphere and pushing the distances of those lights in the sky that you're measuring the return signal for to vast distances. So your presupposed return time is based on how long you assume it'll take, given the distances they are at, if you base the measurements for those lights on a spherical Earth. So your return signal is based on a presupposition, Brenda. When you're looking for that return signal, it's coming back in the time frame you've already decided based on lights that are vast distances because you've made a presupposition that they're vast distances because Earth's a sphere.
No, that's false. It doesn't have the geometry of the Earth has nothing to do with how long it takes for the radar waves to travel from the Earth to Venus and back. The geometry of the Earth has nothing to do with
How
that.
do you get that, Brenda?
That'd be correct. However, in your mathematics, you will be presupposing the geometry of
no,
Earth.
you don't have the
and
Earth,
presupposing
no.
that to those lights in the sky are vast.
No, you don't have to presuppose the shape of the Earth at all. The Earth could be a cube.
You do. That's where you get your vast distances from.
No, you
Yeah?
don't have. No,
That's
the
what
time-
you're doing. You're manipulating the angle using vast distances.
We're not manipulating
You're presupposing a spherical Earth. That's why your return will take a very long time, because according to the presupposition, these lights are very far away.
We're not presupposing anything, Nathan. It's a measurement.
Brenda,
You're presupposing the lights are very far away.
No, you're not.
Yes.
No.
How do you
Yes.
measure?
Right, end of your time here. Fuck off. Hand wave ain't gonna fucking work. Piss off. Stupid bitch.
Ha!